Hi, we are now on the fourth method in finding the general solution of a first order differential equation. And that method is the method for linear differential equations. And at the end of this video presentation, so we are trying to identify if a given first order differential equation is linear or not. And once it was identified, so we are trying to find as well the general or the particular solution of a first order differential equation using the methods of linear differential equation. And by definition, the linear differential equation, or an equation that is linear and of order 1 in the dependent variable y, so must be in this given form. So that's that a of x dy over dx plus b of x times y is equals to c of x. Or the standard form for a linear differential equation would be the differential dy over dx plus p of x multiplied with y, and that would be equal to q of x. So as long as we can see a linear variable on our given equation, so that is either a y or an x, so that could be solved using the method for linear differential equation. So take note that if our differential would be dy over dx, so this equation should be linear in y, so for us to use this method. But if the differential would be dy over dx, therefore then the linear variable should be in terms of x, and the same method would be applied for the method of linear differential equations. So typically, linear differential equations are used in solving first order differential equations in such application like mixture. So let's say we are given a brine solution, so which is a mixture of a salt and water, and then we want to determine how much amount of salt will be present at a certain period of time. So given that there is a solution that is entering the mixture, or it is possible as well that there would be a solution that is going out from the mixture. So the differential equation or the mathematical model that would represent the mixture, okay, the flow on the mixture, so would be resolved using linear differential equations. And if we want to determine, so how much would be the amount of salt at a certain period of time, or if we want to determine, so what would be the rate of the solution that is going in or going out of the mixture, so that can be resolved using linear differential equation. So that is just one among the different application where we can use such method. So let's have the different steps on what to do whenever we were able to classify that a given differential equation is a linear equation. So the first one, we have to make sure that the differential equation is on the standard form, and that is if we were able to identify that it is linear in y, so we are to make sure that our differential would be dy over dx. But if this is x, so this should be dx over dy, and vice versa, this would be p of y, and that would be q of y. And once we were able to transform it on the standard form, the linear differential equation are a type of a non-exact differential equation, and thus we are going to find the integrating factor. But in this case, so we can right away determine the integrating factor to be mu of x, and that is equals to e raised to p of x dx. So our p of x, that would determine our integrating factor. But if it is linear in x, so our integrating factor would be mu of y. But take note that our integrating factor would still be positive, even though that our variable is y. So in that case, that would be e raised to p of y dy. Just to make sure that you are or you won't be confused with the formula that we have for non-exact differential equation. So in methods of linear differential equation, our integrating factor will always be positive, regardless that would be a variable x or that will be a variable y. And once we were able to get the integrating factor, so similar with non-exact differential equation, so we will be multiplying our integrating factor to our original differential equation. And from there, we will be finding the general solution by proceeding with our next step, so which is to integrate. So integrating the product actually of our integrating factor to that of our q of x. And from there, we'll be able to develop our general solution using the method for linear differential equation. Let's move on with our first example, and that is x raised to the fifth plus 3y dx minus x dy is equal to 0. On the given differential equation, so we can see that there are two x on the equation. So one is x to the fifth, the other is x. So therefore, this won't be a linear equation in x. But we can see here that y is alone, and which would make it a linear differential equation, and that is linear in y. So to find the general solution of this differential equation, so we will be transforming the given equation into its standard form. And to do that, so we'll be having x raised to the fifth plus 3y, then multiplied it with the x, and then transforming or transposing the x dy to the right side or the right hand side of the equation, so giving us x dy. And then since we are trying to transform this one into a differential equation linear in y, so we have to make our differential dy over dx. So in such case, we need to remove what is attached to dy. And since we have x there, so we will be dividing the entire equation by x to remove what was attached to dy. And then since we are transforming it into a dy over dx, so I will be dividing it with dx as well. So giving us, so x to the fifth, so divide it with x, so that would give us x to the fourth, and then plus 3 over x, then multiply it with y, and that is equal to, so x would cancel out, so dy over dx. So rearranging our given differential equation into its standard form, and we can see here that we could have dy over dx, and then so the plus 3 over x times y, so it could be transposed to the right side. So in that case, that would become negative 3 over x multiplied with y, and that would be equal to a simple x raised to the fourth. So transforming our original differential equation into a linear differential equation standard form. So in such a case that our p of x here is equivalent to negative 3 over x, and our q of x is equal to x raised to 4. So our next step now is to determine the integrating factor of the given equation. So our integrating factor then, which is equal to the mu of x, and that is e raised to the integral of p of x dx. So giving us an e raised to the integral of negative 3 over x dx, or that will be e raised to negative 3 ln x, or e raised to ln x raised to negative 3, or simply 1 over x cubed. So our mu of x, or the integrating factor, would be 1 over x cubed. And to resolve such equation, so we have a working formula that we can use in finding the general solution of a linear differential equation. And that is mu of x, multiply it to where it is linear. So it is linear in y. So I'll just be attaching y there. And then we'll have the integral of q of x, mu of x, dx. So in this case, our mu of x is 1 over x cubed. Then multiply it with y. That is equal to the integral of our q of x is x to the 4th. And then our mu of x is 1 over x cubed dx. So solving this further, so this would give us y over x cubed, and that is equal to the integral of x dx, or y over x cubed would be equal to x squared all over 2 plus c. So simplifying further our general solution, so by multiplying 2x cubed, so that will give us 2y, and that is equal to x to the 5th plus c x cubed. Or we could have it as 2y minus x to the 5th is equal to cx cubed. So for our general solution. So our general solution would be 2y minus x to the 5th, and that is equal to c times x cubed. So that would be the solution of our first example. So let's proceed with another example. So this time we'll have a y prime. So y prime is equals to x minus 2y. So this is very straightforward, a simple example. So y prime is the same as dy over dx. So we could have a y prime, and then since this is dy over dx, so it should be linear in y. So therefore we will be transposing the negative 2y, so to become plus 2y, and that will be equal to x. So giving us the p of x, so it's linear in y. So the one that is multiplied with y is 2, so therefore our p of x is 2. And our q of x is equal to x. So in the same way, so we will be computing for our integrating factor. So mu of x, so that is e raised to the integral of p of x dx, or that would be the integral of 2 dx. So which is equivalent to e raised to 2x. So using our formula, so for linear equation, so that is mu of x multiplied it with y, and that is equal to the integral of q of x, mu of x, dx. So our mu of x is e raised to 2x, or that would be y e raised to 2x. And q of x here is x, so the integral of x e raised to 2x dx. So again, we are given a product of an algebraic function and an exponential function. So the easiest or the easier way on how to find the integral of such function would be to use a tabular method. So where x and e raised to 2x, so would be our dv. So x then will be, derivative of x would be 1, and derivative of 1 will be 0. The integral of e raised to 2x is e raised to 2x, but our u here is 2dx or 2x, and our du is 2dx. So our neutralizing factor then would be 1/2. And similarly, so we'll have e raised to 2x, another neutralizing factor of 1/2 times a half, so giving us a 1/4. So this would be positive, and the other one will be negative. So next is to write our general solution, so which will be y e raised to 2x, and that is equal to, so positive, so we'll have 1/2 x e raised to 2x, and then minus 1/4 e raised to 2x, and that is plus c. And if we want to rearrange our given differential equation, so we can multiply everything by, so this is 2 and 4, so I could multiply everything by 4. And then if I want to do this one explicitly, or express this one explicitly as y in terms of x, so I'll be multiplying e raised to negative 2x as well. So yielding into 4y, and that will be equal to 2x, e raised to 2x and e raised to negative 2x would cancel out, and then minus 1, and then plus c e raised to negative 2x. So giving us our general solution, so to be equivalent to 4y is equal to 2x minus 1 plus c e raised to negative 2x. So that would be very straightforward. So this time around, so let's try to have another example. This one is dx over du, then plus 1 minus 3u over u times x, and that is equal to 3u e raised to 3u. So in this case, we were introduced with new variables, so instead of x and y, so we have an x and u. And the given example, this is pretty straightforward because it's already on the standard form, so there's no need to manipulate the differential equation to transform it into standard form because it is already on the standard form. So since it is dx over du, so we are expecting that it should be linear in x. So therefore, our p of u here, so right away, so we could write that that would be 1 minus 3u over u, and our q of u will be 3u e raised to 3u. And from there, so we can now find the integrating factor. So that would be mu of u, and that is equal to e, the integral of 1 minus 3u over u du, wherein this is the same as e raised to the integral of du over u minus 3u over u would be 3 du. Or in short, so we'll have e raised to ln u minus 3u. So giving us u e raised to negative 3u. So for our integrating factor, so mu of u is equal to u times e raised to negative 3u. So using our general formula, so the mu of u then, so this time it's linear in x, not in y. So I'll be multiplying it with x, and that is equal to the integral of QU, so which is 3U e raised to 3U, and then multiplied it with mu of U, so which is, okay, so I'll just write mu of U here first, and then our mu of U is U e negative 3U, so times x, and that is equal to the integral of 3U e raised to 3U. Our mu of U is U e raised to negative 3U. Of course, we'll have the U there. And next is, let's simplify it first. So I'll have an x u e raised to negative 3u, and that will be equal to the integral of 3 u times u would be u squared e 3u times e raised to negative 3u, so would cancel out, so that would just give me a du there. And integrating the given equation, so that will be 3, so multiplied it with u cubed over 3, so plus c, so giving us an x u e raised to negative 3u to be equal to u cubed plus c. And from there, so we can express this one explicitly as x in terms of u. So we will be multiplying u raised to negative 1 and a positive e, or e raised to a positive 3u. So giving us x to be equal to, so u squared and then e raised to 3u, so plus c u raised to negative 1 e raised to 3u. So that will be our general solution. That is x is equals to u squared e raised to 3u, then plus c u raised to negative 1 e raised to 3u. And for our last example, so let's solve. This time it involves a trigo function. So 1 plus cosine x multiplied it with y prime, and that is equal to sine x multiplied with sine x plus sine x cosine x minus y. So I guess we don't need the equal to 0 there, because this is already an equation. And we need to transform this into the standard equation for linear differential equation, and that is to leave y prime alone. So to do that, so I'll have the y plus cosine x multiplied with y prime, that is equal to sine x multiplied with sine x plus sine x cosine x minus y. And from there, so I'll be dividing everything by 1 plus cosine x, so leaving us a y prime alone, and that is equal to, so what would I'll be doing, so we'll be distributing the sign, so giving me a sine squared x plus sine squared x cosine x minus y sine x, so all over 1 plus cosine x. And then from here, so I could separate this one into 2. So I could rewrite it as sine squared x plus sine squared x cosine x. Then divide it with 1 plus cosine x. Then minus y sine x. Divide it with 1 plus cosine x. I'm doing this one because this is y prime. So therefore we have to find, so where is it linear? It should be linear in y. And in that case, so there is our y. And then rearranging the equation, so this would give us plus sine x all over 1 plus cosine x and multiply it with y. And that would be equal to this given term. So as you can see, so sine squared x is factorable. So we could have sine squared x, so leaving us to have 1 plus cosine x. So divide it with 1 plus cosine x. So 2 are common, so we could cancel it out. So transforming our differential equation into y prime plus sine x over 1 plus cosine x times y is equal to sine squared x. So as you can see here, our p of x then so would be equal to sine x all over 1 plus cosine x, and our q of x would be equivalent to sine squared x. So from here, so we will be computing our integrating factor. So our integrating factor, so which is the mu of x, so that would be equal to e raised to the integral of sine x over 1 plus cosine x dx. And our denominator is 1 plus cosine x. If we're going to derive cosine x, so that would give us a negative sine x. So therefore, our neutralizing factor, let me rewrite it. So if u is 1 plus cosine x, so our du would be negative sine x dx. So since the numerator is only sine x, so we need a neutralizing factor, so which is negative 1. So giving us this one equivalent to e raised to negative ln of 1 plus cosine x. Or that would be e raised to ln of 1 plus cosine x raised to negative 1. And our mu of x then so would be equal to 1 over 1 plus cosine x for our integrating factor. So to find the general solution, so our mu of x then would be equal or multiplied it with y, and that would be equal to the integral of q of x and multiplied it with mu of x dx. So our mu of x is 1 over 1 plus cosine x, or that is y all over 1 plus cosine x, and that is equal to the integral of sine q of x is sine squared x, then multiplied it with 1 over 1 plus cosine x dx. So to find the integral, so y over 1 plus cosine of x would be equal to, we need to use an identity. And the identity for sine squared x is 1 minus cosine squared x. So divide it with 1 plus cosine x dx. And then, so continuing our solution, so y over 1 plus cosine x is equal to, so we can factor out, so difference of two squares. So this will be the same as 1 minus cosine x. The other is 1 plus cosine x divided with 1 plus cosine x dx. As you can see here, so 1 plus cosine x would be cancelled out. So y over 1 plus cosine x then would be equal to the integral of 1 minus cosine x dx. So which can be integrated at this time. So the integral then would be, or y over 1 plus cosine x will be equal to the integral, or sorry, we could write a way to find the integral. So the integral of 1 multiplied with x, so that would just be an x, and then the integral of cosine would be sine, so minus sine x plus c. So if we want to multiply everything, so by 1 plus cosine x, so giving us y to be equal to, so x plus x cosine x, then minus sine x minus sine x cosine x, then plus c, so multiplied it with 1 plus cosine x. So that would be our general solution. So y then is equal to x plus x cosine x minus sine x cosine x plus c multiplied it with 1 plus cosine x. Or we could just simply write c cosine x, so because 1 will be absorbed by c. So that's all for the various examples involving linear differential equation.